Hey, Paul, how are you?
Good.
Nice to see you again.
Nice to see you as well. Thanks for having me.
Where's your little kit?
It's in my pocket.
It's all in your pockets.
Yeah,
okay.
as cell phones should be, right?
Absolutely. Let's go to the Elmo here. I think we're
Okay. I think they were going to do an
Oh, we're
overhead
going to do it over
camera,
there? Okay,
but,
let's do it over there.
Whatever
over here's better.
Whatever you prefer.
Now, you work at the Google.
I do, yes, I do.
Okay.
For about a week now.
Oh, right, because you were at Motorola.
That's right. That's right.
Let's get this out of the way. Okay, so you're showing me what?
So I'm showing you a high-fidelity industrial design prototype, right? So this is non-functional. I'll show you some pieces of functionality in a second here.
Sure.
And so this is the Project Ara phone, hopefully to be known as the Google Ara in the year to come or so. So the device is modular. There's both front-facing modularity. Let me just remove the display here, as well as rear-facing modularity.
So you're taking your phone apart right now.
That's exactly what I'm doing. That's exactly what I'm doing. And our goal here is to create basically a third-party ecosystem of module developers, is to change the way innovation happens in the hardware space and make it a lot more like the software and app store model.
Or Transformers.
Or Transformers,
as it
that's
were.
right.
So when these come sliding out, just so people know,
yeah.
There's a little bit of a magnetic, which actually you can see the play on it there.
Yeah, that's right.
It's like actually kind of feels nice.
Yeah.
There's a nice hand feel. Reminds me of the cookie dough from before.
Yeah, so if I could explain that for a second.
Yeah.
That's about a 3 Newton permanent magnet.
3 Newton,
so very weak, right?
Yeah.
It's just enough for you to put the modules in and be able to flip the device over without the modules falling out. The functional prototype, which if you could click to the next slide, is it? Oh, I guess the slides go away.
Yeah, the slides go away
okay.
when we do
I have
this.
a picture of the functional prototype.
Here we go.
And if you could click to the next slide, or somebody could click to the next slide.
There it is.
There we go. Yep, so that's the functional prototype, first functional prototype that's under development. It was supposed to boot for this demo.
Oh, really?
It doesn't quite boot, so I brought a module from the functional prototype, so I can show you sort of a functional module. I'll get to those in a second. So this is a real Ara module. It's a Wi-Fi module.
Okay, so we're back to the camera.
Yeah,
Got it.
So we're back to the camera here. And let me remove the enclosure. The enclosures are user serviceable.
User serviceable
meaning that a user can remove the enclosure.
Got it.
And swap it out for a different one. Because not only are we after functional customization here, but we're after aesthetic customization as well.
So Prada could make, or whatever, Hermes could make their own cases.
So you could absolutely do that.
3D printed?
These are 3D printed.
These are 3D printed.
This is a 3D printed one.
Okay.
Here are some other examples of 3D printed ones. We have a big relationship with 3D Systems on this. It's our partner in this program. And 3D Systems is actually developing the first production volume consumer grade 3D printer. And we're also experimenting with printing functional materials like conductive inks to be able to do custom antennas. And I think I have an antenna here.
Wow, so going from cosmetic 3D printing
to also functional. That's right.
Wow.
And so that's an example. This is not 3D printed, but this is designed for 3D printing, right? So this is made using traditional printed circuit board manufacturing methods. And this is the antenna that's in the Wi-Fi module, but it's glued in here. So this is the bare antenna.
So just step back a second. This frame
Yep.
is a battery and what else? Because it's incredibly light.
There is a battery in the frame. Obviously, this is an appearance model, but in the functional prototype, there is a battery in the frame. That battery is very, very small. The purpose for that battery is to act as reserve so that you can hot swap the modules. And that includes the battery modules.
And so this module could be a battery.
It could easily be a battery.
The 2x2.
A 2x2, that's right.
2x2 battery. Or I could do a 1x2 battery.
Or you could do a 1x2 or a 1x1, although that wouldn't be very much battery capacity.
Maybe a small amount.
Any module can be a power source, power sink, or a power storage device. Or anything else for that matter, right? So the modules, the only thing that we constrain is this partitioning scheme, what we call the 1x1, 1x2, 2x2.
Got it.
And we provide to the developer community the module developers kit, which is basically an open platform specification and a reference implementation that allows anybody to create their own modules for this platform. And that MDK is free and open. We'll publish it probably in a little over a month.
So if Yves Bahar, who was on the stage yesterday, says, I want to create a module for a jam box, speaker-ish kind of thing, he could make a 1x1, 2x2, 1x2, or whatever this is called.
That's right. The front-facing modules have a slightly different parceling scheme.
Right.
Or partition
So
scheme.
you could basically have someone like Jawbone make their own speaker system for this, or Beats by Dre.
Yep.
And I could say, you know what, I'm going to a party. I want to put a subwoofer and 4 speakers back here and battery life, but I don't need the camera.
That's right. That's exactly right. And so you could even imagine sharing modules inside a family, right? I think that works better, perhaps that's more appealing to perhaps lower end users who can't afford sort of a high definition camera, but might be able to sort of pool resources to do that. We really set out to design the platform for 6 billion people, and that's 1 billion of existing smartphone users today, and 5 billion feature phone users. And that's part of Google's objectives, right? Is to bring the internet, and in our case, the mobile internet, to the next 5 billion.
So this seems like so super customizable and awesome. It would make me think that it would be more expensive to have this customization. Will it be more expensive at first, or do you have some strategy to make it cheaper?
So,
why would this be cheaper to do something so extensible?
Sure. So there's certainly some overhead to modularity. There's no doubt about that. It's a network on device, right? So we're creating a packet switch network. There's overhead with the magnets that hold the device, the modules in, and the network protocol. And so all of those things absolutely do come with some cost. The countervailing factors are the fact that the consumer gets to decide exactly and only what functionality goes into the device, right? So if you don't use a camera, right, if you want a really inexpensive stripped-down phone, you can do that. In fact, you can get a Wi-Fi only device. And so we talk frequently about what we call the gray phone, which is aesthetically gray to sort of invite expression on the part of the user. And it's a phone that contains just a display, a low-end application processor that still runs Android, of course,
right.
A Wi-Fi module, and a battery. And we're targeting $50 a bill of materials cost for that device, which is the crossover point between feature phones and smartphones.
So there is a lot of margin locked up in a Samsung or, HTC or, Apple phone.
Sure.
And the reason they make so much money is because they're putting all these things together. Is this a move by Google to take out all the margin of the hardware business and just get everybody competing so rapidly on each individual piece that the cost of a smartphone essentially goes to zero or close to zero?
Yeah, so I think we're less interested in people's margins than we are in the pace and level of innovation in the hardware ecosystem, right? So I think that there are plenty of opportunities to make money out of a highly competitive ecosystem, but what we are after is getting the number of brains in that ecosystem up into the tens of thousands, hundreds of thousands, comparable to Android app developers, but just at the hardware level. And we do that by lowering the barrier to participation and allowing component developers, or people who have never participated in the smartphone industry before, right? So for instance, an acoustics company, right, that may not be a mobile component vendor today, could now basically have the ability to market directly to the consumer and see if there is an interest in them entering the mobile space.
So how much would they have to pay you to license your technology to put Beats by Dre in here?
So they don't have to pay us anything. So
$0.
The module, that's right. It is, you can think of it logically as an analog to Android, but at the hardware level. And so in the same way that Android is free and open source and available to anybody to download from the Google website, the MDK, the Module Developers Kit, will be free and open as well.
It's a highly disruptive concept.
Yeah, I hope so. I think so.
Yeah, I mean, if people who make cameras don't have to pay a VIG to get into the iPhone, or Apple or Samsung don't have the ability to say, hey, you have to do it on this terms because we have so much distribution, that could change everything.
Yeah, I think this does have the potential to make the smartphone industry a lot more exciting.
How long before? Yeah, what's that sort of general timeline?
Sure.
If we're here next year, would somebody in the audience have one of these?
Yes, I think so. So that's our goal.
Would that person be a developer or a consumer?
No, so we're getting hardware in the hands of developers much sooner than that. And in fact, so this is the first public announcement of our first Ara Developers Conference. It'll be April 15th and 16th.
April 15th and 16th.
Yep, it'll be online, streamed online, and there'll be interactive Q&A capability for online participants, and it'll also be at the Computer History Museum in Mountain View.
Wow.
People can go to projectara.com and apply to attend.
Just for Project Aria? not for any other Google stuff.
That's right. This is a developers conference aimed specifically at the Ara MDK, walking through the Module Developers Kit and getting people jump-started on the development process. And actually, I don't know if it's possible to get the overhead camera back. I wanted to show the rest of the functional module.
Yeah, let's show the rest of the functional module here. Now, you were saying before, obviously 3D printing cases like this, super, like that's a layup, and now you're starting to see, like, you know, oh, why would I want a 3D printer? Like, hey, I might very much want to print, you know, a new Knicks cover when Carmelo Anthony leaves the Knicks. I could get a new cover, you know, and take him off the back of my phone battery.
Yep.
But wow, you're saying this antenna could be printed in a printer eventually.
And it could be completely custom to the module developer, right?
So what would be, so would that be, I'm in a new country, or I'm going to another country, they have different type of antennas, or I need a stronger signal strength, I'm going to make a bigger antenna? Why would I need to print an antenna?
Yeah, so you could imagine a variety of reasons for doing that. The reasons that you cited, certainly trying to access a different carrier network or whatnot. We're also pretty excited by the form factor that it affords to the antennas, right? It's basically a layered deposition technology. So if you don't mind, let me show the rest of the functional module. So you have the user removable cover here, and so I've removed the cover. It happens to contain the antenna for the prototype Wi-Fi module. Then there is a safety shield so that people don't touch the raw printed circuit board. That would normally be soldered on. I have it removable here to show you the rest of the module. And then you have the printed circuit board that contains the Wi-Fi chipset in this case, and it contains the interface hardware for the Ara on-device network. And it contains here there are spring pins, but in the second prototype, these will be capacitive pads, and that lets us maintain this sleek sort of pebble-like appearance to the modules. And then you have two magnets, and these are special magnets. So I mentioned that the magnets in here are just permanent magnets, about 3 newtons in force. These magnets are electropermanent magnets. So an electropermanent magnet is one that is passive in both the on-state and the off-state, but requires a voltage kick to transition between the two states. And so when they're turned on, the strength of the magnets goes up by about an order of magnitude, so to about 30 newtons, and that's more than you can exert with your finger to pry out the modules.
Right.
And again, the purpose of the magnets is also to sort of overcome this notion of the fact that a modular device has to be bulky and boxy and Lego-like.
Yeah.
And that it can be sleek and it can be sexy and the industrial design can be beautiful. So we went for this pebble-like appearance with no card edge connectors. And we'll be getting rid of the spring pins that are in the first prototype just as soon as we can.
And is the core innovation here this magnet, like ease of use technology? You wouldn't have made it if you didn't have that ability? Because having to snap these in and lock them with a little pin or something, or like one of those tiny switches that you have to try to catch with your nail or a pen, that would have made it really lame, right? I mean,
so I guess I wouldn't say that that's the only thing, right? But certainly getting the industrial design, and that's why we tackle that first, right? Is because getting that to a place where users can be excited by it, where they find this to be palatable and a device that they can love, is we thought was a long pole in the tent for a modular device. And this we may not have been able to do that 10 years ago, for instance, or 20 years ago when things were bigger. So the ability to get the modular overhead down to a manageable level, to under 25% or so, is really the enabler.
These connectors here that transfer data.
Yep, as well as power.
As well as power. What is this technology, and how fast is it? Because I assume that's a key part of this, enabling technology.
Absolutely, absolutely. So we're using a protocol stack from MIPI, which is the Mobile Industry Consortium. So we intentionally chose not to create a proprietary standard here. So this is available to anybody who's a MIPI member. It's called MFI at the physical layer, at layer 1. And it offers about 10 gigabits, per connector block. So the big modules could go up to 20 gigabits. The smaller modules that have a single connector block are 10 gigabits. And so that allows us quite a bit of margin for growth, right? So that the platform can be longer lived than the obsolescence timescales and the technology timescales of each individual component, which can be different, by the way. That's the other interesting thing, right? Is displays have a different obsolescence and technology maturation timeline than processors, than baseband.
Then
cellular
cameras.
connectivity, then cameras.
And
they can all
batteries.
evolve on their natural timescales rather than forcing you to throw away your phone every 2 years and buy a new one.
It seems like the screens get better every 2 years, 18 months?
Yeah, that's probably about right. But like cellular connectivity goes from 3G to 4G to LTE much slower than that, for instance.
Right, that might be a 4-year,
That's right.
5-year cycle.
Exactly.
And so you could just slide out your 4G connector or whatever it is,
That's
with
right.
your antenna and
Yep.
everything, and just start over.
Yep, absolutely. And perhaps, yeah, that's exactly right. Or keep your identity, right, on a single module and move it between
That's an
devices.
interesting concept. So I take out my identity and say, here, take my phone for the day.
That's right.
You can use it. It's
Yep.
all functional, but
Yep.
none of my pictures are on it.
Yep. Or move between phones, or have a work phone and a work the same
I could
phone
have
be
a
a work phone
phablet.
and a home phone, but
Yeah.
just with a swap of a.
Or
of
if I
an
wanted to go from
identity
a
module.
phablet to one with a keyboard, a BlackBerry-style device.
Yeah, so you can do that, all right? So if you remove the front module, there will be, the only thing that's fixed is the location of these connector blocks. I guess I'm not showing this to
Yeah.
anybody other than you.
Yeah, they can see it from there.
But the other thing we're doing is so these endoskeletons, we have a couple of them in the works. So here's a mini version.
Oh, this is beautiful.
That has.
This reminds me of the old like Nokias. Like they had the small, thin.
Yeah, everybody seems to be going towards bigger, and I'm not sure that bigger is better.
Well, I mean,
and so here the consumer gets to choose again, right?
Yeah, and this has these 1x2s. So if one of these was
They're interchangeable. So
right, I could take the camera and I could just swap out the camera and my. Well, that's interesting. They magnet together. I could swap out the camera and my memory chip and my SIM.
Yep.
And move it to my bigger phone and back.
That's exactly right. And the endoskeletons, that's what
Yeah.
we call the sort of the backplane here. We expect them to be fairly inexpensive. So they do very little other than just routing data packets. It's a network switch. And
So these endos would be tens of dollars maybe or something.
That's right. That's
yeah,
right.
not expensive.
Yeah, we're targeting about $15 for an endo.
How many endos do you think you'll have? And can the endos connect to another endo? So could I put two of them together and make myself like literally a small tablet that had 4 screens or 5 screens?
Yeah. So for starters, we're developing 3 different endos. We have the mini, the medium, and we have a wide sort of phablet size that I don't have a model of here, but it basically has one of the 2x2 modules or 1x2 modules on both sides of the spine. So you
Very
can imagine
nice.
it being a third wider. And in terms of connecting endos and creating sort of things that are no longer smartphony, I think there's a lot. I think the possibilities are actually limitless. But one thing that I've been very keen to do with the program is to make it first and foremost a great smartphone, rather than trying to focus on lots of different things and potentially ending up with something that's kind of mediocre at a lot of things. So I want it to be great at one thing and then
Right.
look at the crossover points.
And the only thing that Google owns in all of this is the endo core enabling technology. Everything else is up for grabs. Anybody can participate.
That's right. Anybody can participate. Certainly we want to maintain some control of the platform, right?
Yeah.
To ensure that there's a cohesion to the developer community, that it doesn't get fractured as we start building it up. But we invite anybody to join the developer community.
Are you scared that this thing is going to crash constantly as people make, people will go off the reservation and make all kinds of crazy stuff. You plug it in, your machine crashes, it freezes, and people just blame it on, the Google modular phone sucks because it crashes, and it really is the fact that, somebody made a just poorly designed module.
Yeah, I mean, it's certainly a consideration. I think that, so we intend to create a modular marketplace with a configurator app, that allows you to do all of this customization and sort of manage the choice that consumers are faced with, both functionally and aesthetically. And that marketplace will have some certification and credentialing scheme associated with it. I think it'll be much more like the Google Play Store than the iTunes Store in terms of the level of invasiveness of that certification and credentialing.
So you will have to be certified to be in the store?
That's right, to make it into the store. But you can sell modules outside the store, and consumers, in the same way that you can download an Android app outside of the Google Play Store, you just have to go change a setting in your configuration and sort of assume the risk.
Yeah, I will allow my machine to crash.
That's right. Yeah. That's right. And it's not going to be completely foolproof, right? I mean, I have apps that crash on my phone all the time.
Yeah.
But we think we have enough safeguards being built into the platform from a thermal management perspective, from a power management perspective, that there's no safety hazard.
I predict,
and then if a module is a bad module, right, then the phone will stop working, the user will take it out and know not to buy that module anymore.
I'm predicting next year we're going to have a couple of companies on this stage who are launching module technology
I hope so.
as a startup. I mean,
Yeah.
if this winds up getting some kind of adoption in the way Google has with, say, Chrome or Android,
Yep.
my God, this could be an amazing ecosystem to build a startup on making phone, cameras.
Cameras, or we think a particularly fruitful area is going to be personal medical diagnostics and devices for accessibility.
Oh, wow.
We think that's pretty exciting, something that would never make it into a mainline device from a big OEM today.
So a screen for somebody who's specifically nearsighted or farsighted.
Sure, or imagine a spectrometer module that can do rapid analysis of fluids, right, or air or something like that, right, for diagnostics, environmental monitoring.
So this starts to turn into the tricorder or something.
For instance, and that's very personal,
You
right?
seem like a Trekkie to me. Are you a Trekkie?
I am a space cadet, I admit it. I'm actually an aerospace engineer by training.
So you were in aerospace and you went for this project. Why? I mean, you could be working at SpaceX, right? You're some smart guy.
So I came to Motorola and then now Google from DARPA. And the organization that Project Ara is being developed in is called ATAP, Advanced Technologies and Projects, so it's now Google ATAP. And we have a pretty interesting premise, which is to try the DARPA innovation model in the private sector. And so that is a fairly short duration, very intense, focused projects that are at the intersection of fundamental science and a driving moonshot type practical application. And we use external communities of performers. So there are actually 3 people at Google, myself included, who work on this project. But there are hundreds of people, around 100, probably a little north of 100, dozen or more performers that are external.
What's it like to work for Larry and Sergey? I mean, they must love you because this is like a great, crazy moonshot. Do they say, hey, I'm coming by to visit you? Do they interact with you on a regular basis? Or is it like, see me when you're done?
So I am new to Google. I did have an opportunity to brief Larry early on in my tenure at Motorola on the project. I think it is very resonant with Google values in general, right? And I think our objectives of revolutionizing and democratizing the hardware ecosystem and reaching, on the user-facing side, reaching the next 5 billion, I think are pretty well aligned with.
And they'll just give you whatever resources you need for a project like this, right? Like, they're not stingy about like, hey, spend money and try to make this work. It's just like, hey, go for it.
So I guess I would phrase it this way. I think that that ideas are in shorter supply. So I think we're idea limited rather than resource limited.
Project Ara is going to be held on the first webcast will be at what website? Where would we go?
ProjectAra.com.
Oh, okay.
And that website went live.
ARA.com.
ARA, right. ProjectARA.com.
And April 16th, you said?
April 15th and 16th.
So April 15th and 16th, they can go to ProjectAra.com and watch and learn.
Yep.
And if they want to participate at the Computer History Museum, they got to just email you and get a...
Yeah, so there's a registration page, both for online and for in-person participation. And we certainly welcome both. And also developers of all shapes and sizes, right? So from startups all the way to large OEMs, non-traditional participants in the smartphone industry. We really want to break it wide open.
Awesome. Paul, this is amazing stuff, and congratulations on the progress. And let's give a big round of applause for showing us the latest. Awesome.
Thanks very much.